Dear students, welcome to our science episodes. Today we are going to discuss graduation of elements in the modern periodic table. Look, this is the modern periodic table. And do you remember that elements are arranged in the modern periodic table in ascending order according to their atomic numbers in periods or rows and groups or columns? What is the atomic size? Atomic size is the radius between the nucleus and the outermost shell. This is the length, or we call it the radius of the outer circle. This is called atomic size, and it is measured in picometer. Picometer actually is equal to this number, 1 times 10 to the power -2 meter. Can you see this picture? What do you notice? This is the distribution of atomic sizes of elements. So atomic size increase in this direction and in this direction. So going from up to down, the atomic size will increase, and going from the right to the left, the atomic size will increase. Now we are going to see the relation between atomic size and the attraction force of the nucleus to electrons in the outermost energy levels. Now we are going to compare between different elements according to the attraction force between the nucleus and the outermost energy level. Look to these two elements. This is sodium with 3 energy levels, and this is lithium with only 2 energy levels. Which atom has more attraction force, do you think? The atom with the less radius. So it's lithium because it's smaller than the sodium. So this atom or this nucleus will have more attraction force for electrons. Another 2 elements, oxygen with 2 energy levels and fluorine with also 2 energy levels. So what is the difference between the 2 elements? The difference is the number of protons and the number of electrons as well. 8 protons and 8 electrons in oxygen, and 9 protons and 9 electrons in fluorine. So if both atoms have the same energy levels, the nucleus of fluorine has more attraction force because it contains more protons than the oxygen of atom, as if this nucleus is more powerful. So it has more attraction force because it has more protons. It's fluorine. In the same period, elements have the same number of energy levels and increasing atomic number. Let's look in this period. Atomic size will increase in this direction from the right to the left, while the atomic number will increase in this direction from the left to the right. Actually, the relation between the atomic size and the atomic number in periods, in rows, is inversely proportional. They are opposite to each other. What about in groups? Can you see this? Both atomic number and atomic size increase while going from up to down. Actually, the relation between atomic size and atomic number in the same group is directly proportional. Do you notice this element with symbol CS? It's cesium. Cesium has the largest atomic size, while fluorine has the smallest atomic size in the modern periodic table. Did you ever hear about covalent bonds or even covalent compounds? Let me show you. Covalent bond is a chemical bond when two atoms share their electrons together. Look to this. Two atoms, they share the electrons together. These electrons shared between two atoms are called covalent bonds. Electronegativity property. What is electronegativity? It is the ability of the atom in the covalent molecule to attract electrons in the chemical bond toward itself, forming polar compounds. So, as if there is a force of attraction between the nucleus and the electron, the ability of the atom in the covalent molecule to attract electrons. So let's see in the previous slide, if these two atoms are sharing electrons together, which atom is able to attract the electrons to its side and become polar? This is called electronegativity. And of course, the atoms with small atomic size or small radius are having greater electronegativity. Let's see together the electronegativity property across the groups and the periods of the periodic table. Electronegativity increases in this way, from the left to the right, together with the atomic number. So it's a direct proportion relationship. While in groups, they decrease in this way, from up to down, while the atomic number increase from up to down. So actually the relation is inversely proportional. They are opposite to each other. So electronegativity and atomic number increase, both of them increase in this side, and they are opposite to each other in groups. This is the difference between elements and compounds. An element contains only one kind of atom. When I'm talking about oxygen element, so it's only oxygen. When I talk about helium, it's only helium, nothing else. But in compounds, there are more than one kind of atom, two or more. So in the compound water, there is hydrogen and oxygen. In the compound carbon dioxide, there is carbon and oxygen, and so on. What are the types of compounds? Polar covalent compounds, nonpolar covalent compounds, and ionic compounds. And we will be concerned with polar covalent compounds in the next slides. Here we go. Can you think for about 1 second why the polarity of water compound is more than that of ammonia? Of course, both of them are compounds because more than one kind of atom. So I'm telling you that the polarity of water is more than the polarity of ammonia. But why? Let me explain for you something. The difference of electronegativity between hydrogen and water is more than between hydrogen and nitrogen. So that's why polarity of water is more. Do you remember electronegativity? Yes, it's the force of attraction of an atom to the shared electrons in the covalent bond. Why do you think noble gases have no electronegativity? These are examples of some noble gases: helium, neon, argon. And they are inert. They do not participate in chemical reactions at normal conditions. They do not have electronegativity. Time for questions. Fill in the blanks. What and what are examples of polar compounds? Yes, I stated 2 examples for polar compounds here in this episode. One of them is water and the other is ammonia. Number 2, which element has the largest atomic size in the periodic table? Can you remember? It's cesium. The radius of the atom is measured in, of course, this is the atomic size. It's measured in picometer. Next question. If you have these 3 elements, one with 19, one with 17, and one with 11, which element has the smallest atomic size? First of all, we have to determine the electronic configuration. Here are the 3 electronic configurations. Look to the electronic configuration and tell me. Look to the number of the outer energy levels and tell me which one has the smallest atomic size. Element with atomic number 17 has the smallest atomic size, and the one with the atomic number 19 has the largest atomic size. Dear students, thank you for watching and see you later in other episodes.